Good afternoon or good morning, good evening, depending on where you are, and welcome back to the second part of our symposium on research integrity. Excited to have you all still with us. One thing I should have mentioned before, especially for the audience here in the room, is that this event is being recorded. So, I mean, you're not going to be in the picture a lot of the time, because mostly, obviously, it's focused on the speakers, but I just should have let you know before, so I apologize for forgetting that before. For those of you who are participating online and who may have just tuned in, if you want to interact with us here, use the Q&A button to ask questions, use the chat functionality to leave comments, to share your thoughts with the other participants. But make sure you use the Q&A for asking questions to the speakers, because questions in the chat won't reach us here. It is my pleasure to introduce our next speaker. It is Professor Vincent Larivière. He holds the Canada Research Chair on Transformations of Scholarly Communication at the University of Montreal, where he is also Professor of Information Science and Associate Vice President of Planning and Communications. His research focuses on science policy, scholarly publishing, and diversity and equity in science. He is also Associate Scientific Director of the Observatoire des Sciences et des Technologies, a research center devoted to measurement and assessment of science, technology, and innovation. And he is a regular member of CERST, which is an inter-university center for science and technology studies. He's going to speak on a topic that we haven't touched on here today. The title for his talk is Why Diversity is Important for Research Integrity. Professor Larivière, welcome, and the screen is yours.
Thank you so much for the invitation. Very happy to be here, but I'd be happier if I was with you guys in person. Okay, I see my screen is up, but I've shared the wrong screen, so let me do that again. Voila. Good. So yeah, we're going to talk a bit about diversity and how it's important to research integrity. And I say to science in general. Now, how diversity, the diversity of the research community can be associated with good, with doing good science in general. My talk is going to be in 4 parts. So I'm going to start by basically describing the lack of diversity, looking again mostly at the gender component, so the gender gap in production, collaboration, and scientific impact. Then we're going to look at how scientific work is divided in nowadays research, and looking a bit at authorship disputes, which one could say is one part of research non-integrity in a way. And then the last 2 parts will be more on the effect of diversity on research itself. So the effect of diversity on the type of research that is being conducted, and that's going to be based on a case study in medical research. And then diversity, and in that last part, it's going to be both gender and racial diversity, so based on research on the US context, and the research topics that are being studied. So many people tend to believe that the issue is solved, at least from a gender diversity point of view. Women have obtained basically half of the degrees in science and medicine since the 1990s. So again, from let's say, the beginning of the pipeline, things seems to have been solved, but still what we're seeing is that women represent basically 1 researcher out of 3 at the world level. So let me give you the global picture. So what you're going to see is a world map where basically each country is color-coded by their proportion of women researchers. And so as you can see on the map, all of the countries that are in orange have a higher proportion of women researchers. Of course, most of you don't see any orange, and that's actually normal. Those of you who see a lot of orange, you may have to go see your optometrist. But basically, there's a handful of countries where women account for the majority of research. And one could say there's only a handful of countries where we've reached parity in the gender distribution of researchers. There's a tiny country in the Baltic that's called Latvia that basically has a higher proportion of women researchers. And out of the countries that have, let's say, a sizable amount of research papers published, it's the only one that reaches more than 50%. One could try to look at this country as an example of gender parity, and in some ways it is, but in some others, it is not so much. And basically, the main driver of having gender parity in the case of Latvia is the fact that the male or men life expectancy is 10 years younger than that of women. So in other words, there's actually more women in the research ecosystem because men die at a younger age. So there's not so much policies or good policies, one could say, that we can implement based on that, which basically means that at world level, there's really a huge gender gap. Of course, it's higher in some countries in Africa, in some countries in the Middle East. Things are a bit better in South America. They're a bit better in many European and Nordic countries. But by and large, we are in a scientific community that one could say lacks diversity from a gender point of view. We can also color code countries based on not so much the 50% breaking point, but based on the average. So at the world level, there's basically 31% of women authors. Countries in orange have reached are above average. Countries in blue are below average. But again, the picture stays the same, with some regions of the world having a bit more issues than others. We've tried to look at what could be the drivers of those trends, and actually, at least at the macro level, there is not really one factor that explains, let's say, the gender gap, or that kind of affects it more. The highest that we could find actually is the one in the middle here, which is the male-female gap in life expectancy. Where again, it's basically the Latvia example, but observed at the level of all of the countries. And that's basically the factor that affects the most the participation of women in science. So basically, countries that have a higher GDP don't necessarily score better. Countries that have higher women in the national parliament, or women in the place of, in spots of ministers and etc., don't necessarily score better. Countries that are more egalitarian from a Gini point of view don't necessarily score better. So again, it shows that it's a multifaceted problem that is, again, pretty much observed everywhere, and for which there's not a simple solution. Of course, the situation is improving. We don't have so much historical depth in that data, unfortunately. This is, again, data based on scholarly publication. We do see a slight increase in most of the fields. Psychology, for instance, has increased tremendously. But if you look at the let's say, fields at the bottom, so engineering, math, and physics, they're actually relatively stable, which means that when you do these simple predictions on how long would it take for the scientific community to reach parity, well, we see that in math, physics, and engineering, it won't be in our lifetime. So basically, in the case of math, we're looking at 2,270 or something like that. So we are not there yet. The lack of diversity and the gender gap in general is observed, of course, from a production point of view, but also in terms of the practices. So women in every country are much more likely to collaborate domestically, so to collaborate at the national level, and men much more likely to collaborate internationally. So their networks are relatively different, and therefore the visibility of their research work is different. And we actually see that, again, from a citation point of view. So what this figure shows, and we can look at just the first author, which is on the left side of the figure. The line at the bottom basically presents the men-woman gap in impact factor. So basically the venues in which they publish. And we do see that there's a slight gap, but not so much. There's even fields where women actually publish in journals that have a slightly higher impact than those where men publish as first authors. But then from a citation point of view, the gap is quite sizable, going from about 15% in medical research to a bit lower, 2 to 3% in biology and social sciences. So what this shows is that women are globally able to publish in journals that are, let's say, of similar reputation, but within those journals, their papers are less cited, and in some subfields, quite to an important extent. And this is particularly true, this gap in citations between vis-a-vis the impact factor, particularly true for journals, for publications in journals that have a higher impact factors. It's not so much for the lower bounds of the impact factor, but more in the higher bound. So lack of diversity of the research community and difference in visibility between men and women research. Moving on to the second part on division of labor. So of course, science, as we've seen, is a collaborative endeavor. The vast majority, basically more than 90% of all research papers are done in collaboration. It's a bit lower in social sciences, but much higher in the medical and natural sciences, which means that there's groups of researchers who divide labor among themselves. And more journals are actually providing information on who does what. Of course, that brings in some issues of research integrity, because typically it's going to be the corresponding author who's going to label or decide who did what. But globally, I think it's an important step toward transparency. So as you can see here, we do have the detailed contribution of who did what. So who conceived the experiment, who performed the experiments, who analyzed data, who contributed some materials, and who wrote the paper. So in that division of labor, we're also seeing, one could say, lack of diversity or the existence of a gender gap. So what you have here, and you can look at the top of the bottom, is just a different depiction of the same result. You have the analysis, design, material, performing the experiment, and writing tasks. So those are the 5 contributorship statements that we had in PLOS journals a couple of years ago. We see first, and the x-axis is the age of the researchers. We see that, of course, the type of contributions that people do vary as a function of age. So you are more likely to write the manuscript when you're an older researcher. You're also less likely to perform the experiment, to actually do the science. You have your hands in the manipulations, etc. But we also see in the case of performing the experiments where we have the highest gender gap. So basically, at any scientific age, women are more likely to be doing the science, to actually be performing the actual experiments. And this is quite an important thing. When we move on to a new typology, which some of you may be familiar, so a couple of years ago, there was an attempt at creating a standard, basically, of the various tasks that researchers could do. And so they came up with the credit taxonomy, which basically divides scientific activity into 14 different tasks. And the beauty of that, compared with the previous taxonomy that I presented, was that writing the manuscript was just one category. So as you see here, there's writing the manuscript, and you see that men are more likely to be writing the manuscript when you combine that, when you have only one label here. But when you actually have a division in the writing of the manuscript between writing, review, and editing, which means doing the minor edits on the manuscript, and writing the original draft, you actually see an important gender difference here. So men are much more likely to be doing edits on a manuscript, while women are actually much more likely to be writing the original draft. I'll go briefly on that, but we also see a couple of other interesting points where, again, women are more likely to be doing the investigation, which is the equivalent of performing the experiment in the previous slide, and men much more likely to be doing more of the senior-ish type of resources, so conceptualization, resources, supervision, and funding acquisition, which again shows, one could say, a lack of diversity on who leads research teams, on who gets funding, on basically who decides what type of science will be done versus who actually does the science. Then, of course, there's disputes on a regular basis regarding authorship. Authorship is something that is crucial to scientific advancement. And yeah, so we did a big survey of around 6,000 authors that was published about a year and a half ago. And we asked them basically if they ever encountered disputes from a naming point of view. So should you be an author or not on that paper, on the ordering of the authors, and on whether they should have been acknowledged. Very little disputes on acknowledgements, but in every field, women were more likely to have to actually have encountered a naming and an ordering dispute. And this was observed in pretty much all fields. In medical sciences, the numbers are not significant, as you can see, but in both natural sciences and engineering and social sciences, women much more likely, again, to be involved into a naming and an ordering dispute, and in the natural sciences, even an acknowledgement dispute. So again, interesting effects on, one could say, attribution of scientific capital and, in a way, research integrity. Now moving to the actual effects on this lack of diversity on the type of research. So the first analysis that I'm going to present is related to medical research. So that's a piece that we published almost 2 years ago. Actually, no, time flies. There was a pandemic somewhere, so I think it's probably 3 years ago, on looking at the composition of team and how it affects sex reporting. So there's been a move in the last couple of decades towards making sex-based analysis. So we know basically that male and female don't react in the same manner to drug, are actually in many ways biologically different. So there's basically sex-based difference that are observed both at the genetic, cellular, biochemical, and physiological level. But many of the studies were actually done either with male patients or male rodents or male cells, and there was not really a lot of analysis that actually compared how male and female reacted to that. And globally, a poor representation of female population into medical research. So what we looked at here is how sex reporting evolved over time. So our researchers increasingly taking sex into account into their analysis, but even more importantly for our purpose here, how does the composition of the team, so how is the fact that you have a team of only men or a team of only women affecting the fact that you would take sex into account into your analysis? And I'm sure you know the answer already, but I have to go through my talk. So first, very important differences across disciplines in the fact that sex is taken into account. So of course, in biomedical research, where one could say you're working more often at the cellular level, there's more rarely a mention of the sex of the cells, etc. So as you can see, the gray line, relatively high, 70% of research don't take that into account. But increasingly, since the early 2000s, researchers are actually making sex-based analysis, so both sexes are actually taken into account. In clinical medicine, we also see a similar trend, but actually the numbers are even higher. It's still not yet the majority of research that actually takes both sexes into account, but we're getting to close to 50%. Then in public health, again, a similar trend to that of clinical research, clinical medicine, where basically since about 2018, or actually lower than that, about 2015, the majority of research actually does a sex-based analysis, compares the how male and female are reacting to any type of experimentation. Of course, that varies across specialties. So, of course, a field like fertility or obstetrics or urology have a sizable sex component. But what is actually a bit more, I would say, problematic is when you look at the bottom of the left figure on clinical medicine, where you actually see that pharmacy is really, really low on that level, and so is pharmacology. And again, keep in mind that of most drugs that are taken out of the market because they have adverse effects, in most cases it's because they have adverse effects for women. So there's actually an important component here where drugs need to be tested appropriately and sex has to be taken into account in these analyses. And these fields are actually those with the lowest level of sex-based analysis. Now moving to the actual effect of the team composition. So what we basically did here is taking all of the other factors into account. The fact that you have a gender diverse team of author leads to a higher chance of taking sex into account. So as you can see at the top here, so either men as first and women as last, or women as first, men as last, and even better, a team that was led by two women as first and last author was actually much more likely to incorporate sex into their analysis and in a way to actually perform science that is more robust, that is actually stronger, and that can be applied to broader contexts. Last analysis, the effects of diversity on research topics. So it's not about taking sex into account, but it's really looking at what types of social groups work on what. So there's actually topics that are more related to social good that are one could say of greater importance. Is the gender and in that case racial composition affects what people work on. And so this is really based on the United States. So race is a social construct that does not apply in the same way in different countries. In Canada, for instance, race does not actually exist. This is not a statistical category by the government. In the United States, they have six races in their census, which are clearly labeled and that are actually self-declared by people who participate in the census. So what we're looking at here is really the relationship between the identity of researchers and the research fields in which they work, both the research fields and the topics on which they work. So we basically have overall 8 categories: Asian, Black, Latinx, and White, which are broken down by men and women. So globally, there's important differences across fields. So what you have on the x-axis here is the 8 categories that I've just mentioned, and on the y-axis, basically the different disciplines. And the more blue the cell, the lower the representation of the group in that category, and the redder the cell, the higher the representation. So we really see that women of most races are more active in health and much less likely in engineering, technology, math, and physics, which is a typical gender gap that we're observing. But as we'll see, there's actually a bit more to that from a topic point of view. So,
Vincent, can I quickly interrupt you there? We're almost out of time, so if we want to leave time for a couple of questions. Left.
All right. Yeah, I'm going to be very, very quick. Okay, so let me move to the counterfactual then. So what we're doing here is how would science look like if the research community was representative of society? Because we know that there's a gap in who does science in the United States. It is the case in every country. So basically, if science was representative of society, there would be much more public health research, much more nursing, much more social work, much more of those fields that one could say have a lot of social importance, and much less engineering, which I don't mean to say that it's less important, but we see that it matters in terms of let's say it has different social implications. And last one, which I find even better, it's not at the field, but at the topic point of view. So there would be much less research on stock market, economics, and all of that, and actually much more research on learning, teachers, child violence, etc., which I think are of crucial importance for society. And so to conclude, diversification of the scientific workforce is essential to produce the most rigorous and effective and efficient and fair medical research. The people who do the research influences the way research is done. And if we want to have the best scientific community, both from a topic and integrity point of view, we need to have a diverse pool of researchers participating. Thank you so much.
Thank you so much. So this probably was one of the most efficient talks that I ever saw, so thank you a lot. So we have some time for questions. Anyone from the audience here or online maybe? This was obviously a lot to process, but it was also super helpful and revealing. Well, so maybe sort of one quick thing, which is perhaps sort of an obvious question, but can you speak to what evidence we have about effective interventions? So what should be done to make meaningful changes here?
Yeah, that's actually a good question. There's many actions that can be made at many levels, but let's say at the level of, I'm thinking of one thing that was done, I think it was in the Netherlands, where your scientific organization or your Royal Society decided to only nominate women for a couple of years to compensate for the lack of nomination of women for a little while. So I must say that I'm a big fan of quotas, because they actually force people and force organizations to go and find a great woman, which may not be as visible because of all of the social forces that we're seeing. But quotas, I think, is an amazing thing. It's a temporary measure, but it reequilibrates the system. And actually, once the system is more equitable in general, it actually makes better decisions for the future. But that's one simple intervention.
Sure. Yeah, thanks. Anyone here? So there's a question from the online audience, which is about the Matthew effect. How do you think that's related to this issue of diversity, and is there anything we can do to break that effect as it pertains to diversity?
Yeah, that's a good point. Of course, Matthew effect is basically the richer you are, the richer you're going to get. We know that men have more capital in the system, and therefore it's easier for them to accumulate more. One way to break it, and I don't want to sound like a broken record, is actually to grant capital and therefore prestige to women and other minorities using either quotas or just having. Yeah, I think quotas remain the one of the very important tools that we can use to do that. So that's one way to break it. The Matthew effect is a complex thing that, of course, there's also the institutions and the journals that play a role, but quotas can be applied at the journal, at the institution. We have and I'll go quickly on that, we have a program in Canada that's called the Canada Research Chairs Program, which gives prestigious chairs to researchers. And historically, it used to have a huge gender gap. And at some point, the program said we need to have 50% of women in the program, and it worked. And we found a great woman that otherwise would have remained invisible, breaking in a way the Matthew effect.
Right, good. Well, I mean, you may sound like a broken record, but at least it's a good song, so don't apologize. Thanks so much for joining us here, and we'll talk more in the panel later.